echoes from the edge of time and the gamble of humanity. At the very edge of nothingness, where the concepts of time and space begin to blur, a galaxy exists in silence. Its light, a weary and solitary stream of photons, has performed a journey through the darkness of the void for 13.4 billion years to reach our mirrors. When that light first departed its home, our universe was still a newborn infant, having experienced only 290 million years of life. But something is amiss, a crack in our belief system. That galaxy was already full of oxygen. According to everything we once knew about physics, this is an impossibility. Oxygen requires the birth and death of many generations of stars to form, a process that should take 1 billion years. So, how could such a complex entity be present at the very dawn of all things? Do we truly understand the timeline of life, or are we merely imposing our narrow yardsticks onto a universe that is inherently limitless? The existence of this galaxy has triggered a seismic shift in the academic world. Scientists have named a survey after it, Mirage or Miracle. One astronomer at the University of Kansas lay awake during a white night, staring at the ceiling at 3 in the morning, wondering with a vague fear if everything she had ever worked for, every theory she had ever taught, was a grand mistake. Even a Nobel laureate exclaimed to the world in a tone of both astonishment and anxiety, "We have misunderstood the universe." How would you feel if you woke up tomorrow morning and realized the origin of every atom of oxygen in your lungs and every particle of iron in your blood did not follow the laws you have believed in for so long? This story does not begin with those distant galaxies, but at a launch pad deep in the jungles of French Guiana, where tropical humidity mingles with the scent of rocket fuel. It was Christmas morning, 2021. While children around the world were eagerly tearing open wrapping paper in a small corner of South America, an Ariane 5 rocket carried the destiny of an entire scientific field on its shoulders. Inside the nose cone was the James Webb Space Telescope, a masterpiece crafted from gold and beryllium, a machine that cost 30 years of life for thousands of people and $10 billion of humanity's wealth. And when there were no cheering crowds in the streets for this departure, those who truly understood what was at stake were too terrified to celebrate. In control rooms in Baltimore and Paris, the most elite engineers sat motionless, hands tightly clasped, eyes fixed on screens with dancing numbers. They had spent years running every failure scenario, every bolt that could shear, every motor that could jam, every circuit that could short and plunge into darkness. They counted 344 single points of failure throughout the deployment process. 344 moments where a single mechanical error or one stubborn latch could turn $10 billion into the most expensive piece of space junk in history. There would be no shuttle to fly up and repair it, no second chances. Webb plunged into the night alone, and the distance between it and any helping human hand grew by the second. Why did we accept such a massive gamble? The answer lies in the nature of light. Hubble, the great predecessor, saw the universe primarily through visible light. But the universe does not stand still. It is expanding. As space is stretched, it pulls the wavelengths of light with it, shifting the visible and ultraviolet light from the dawn of time into the faint infrared spectrum. To see that first light, we required a massive golden mirror 6.5 meters wide and a working environment of extreme cold. Imagine a mirror as wide as a large living room, yet shrunk to fit inside a rocket. Engineers designed it to fold like the wings of a bird and then unfold in the vastness of space. To maintain a temperature of -447 degrees Fahrenheit, colder than the void between stars, they equipped it with a 5-layer sun shield as thin as human hair, but the size of a tennis court. One side of the shield endures the searing heat of the sun, while the other side, where the mirrors and instruments are placed, drops to nearly absolute zero. That temperature difference is separated by only a few feet of Kapton film. Have you ever wondered if the boundary between existence and nothingness, between searing heat and freezing cold, is sometimes as thin as a strand of human hair? After 29 dramatic days, when the 18-segment golden mirror converged into a single perfect plane, in March 2022, the universe seemed ready to tell its story. But what it revealed was not a gentle confirmation of what we knew, but a defiant challenge to the entire system of human knowledge. For decades, cosmologists had built a model called lambda cold dark matter, LCDM. It was a magnificent theoretical framework built upon thousands of calculations and observations. It stated that the universe is made of 5% normal matter, 27% invisible dark matter, and 68% mysterious dark energy. Its laws were clear. Structure forms from small to large. Small first stars gathered into dwarf galaxies, and over billions of years, they merged to create giant galaxies like our Milky Way. All previous Hubble observations pointed in one direction. The further you look into the past, the smaller and more primitive galaxies become. The universe was arranged in an orderly, elegant, and consistent manner. But on July 12, 2022, when the first scientific images were released, a sense of unease began to spread through research labs. Richard Ellis, one of the world's most veteran astronomers, looked at the data and felt a chill when he found monsters in the very first frames. Early galaxies should have been faint fragments, but before their eyes they were massive, brilliant, and possessed an absurdly complete structure. They violated the timeline of cosmic history just as a fully grown oak tree would violate the explanation that it grew from an acorn planted only last week. If the LCDM model is the foundation of the cosmic house we inhabit, James Webb has just stepped on it and created deep cracks. And will we try to patch those cracks with temporary theoretical fixes? Or are we brave enough to admit that the house needs to be rebuilt from scratch? There is a grim truth in science. Great theories never collapse overnight. They die a slow death under the weight of absurdities that no one can explain. The question hanging over every scientist now is, why was the universe so busy before we thought it could even begin? Could the darkness we call the cosmic dark ages actually contain the seeds of an order we never imagined? And as we reach the limits of knowledge, are we seeing reality or only illusions created by our own biases? Monsters in the nursery and the rebellion of the elements. The early universe, according to what we once taught in university lecture halls, was a quiet and simple place. It began as a uniform fog of hydrogen and helium, where matter had to take hundreds of millions of years to gather enough density to light the first stars. It was a slow process, a nursery where tiny entities had to grow in sequence. However, when Webb's golden mirror turned toward that darkness, it did not find infants just learning to walk. Instead, it found monsters that had fully matured, looming in the middle of a room intended for newborns. In February 2023, a study published in the journal Nature left the entire astronomical community breathless. A team led by Ivo Labbé and Erica Nelson identified 6 candidate galaxies existing around 500 to 700 million years after the Big Bang. Their mass, up to 100 billion times the mass of the Sun. Consider this. Our Milky Way took 13 billion years to reach its current size. Yet these galaxies did something comparable in less than a billion years. How could nature forge such massive entities in such an impossibly short amount of time? Could the timeline we have trusted for so long actually be a flawed sketch of reality? Initial skepticism was inevitable. Veteran scientists clung to measurement errors, suggesting these might just be dust or active galactic nuclei, AGN, deceiving infrared vision. But then the real miracle appeared through spectroscopic confirmations, the undeniable chemical fingerprints of matter. Spectroscopy does not offer vague guesses. It provides definitive assertions. The galaxy named JADES-GS-Z14-0 was the decisive shot. With a confirmed redshift of 14.32, its light departed when the universe was only 290 million years old, having passed through only about 2% of its total history. Sure, but the real shock was not its age, but what it hid inside: oxygen. Remember, the Big Bang did not create oxygen. It only produced hydrogen, helium, and a bit of lithium. Every atom of oxygen you are breathing right now had to be forged inside the massive nuclear furnaces of stars and then cast into space through violent supernova explosions. For oxygen to appear in quantities sufficient for Webb to detect from 13.4 billion light-years away, that galaxy must have already hosted at least one, or even several generations of stars that lived, died, and were reborn. According to the Standard Model, this process takes at least 1 billion years. JADE's GS Z14-0 completed it in 290 million years. It's like finding a teenager where you only expect babies, researcher Sander Scholz remarked. If oxygen was already present at 290 million years, yes, it means the first stars must have formed much earlier than that. What triggered that process? How much of cosmic history remains hidden in a doorway we haven't even learned how to open? The seismic activity did not stop there. Just weeks later, another miracle was announced. The galaxy MOM-Z14, existing at 280 million years after the Big Bang. It was not a chaotic cloud of gas, but a structured, organized entity undergoing a powerful burst of star formation. MOM-Z14 carried chemical signatures of nitrogen and carbon in high ratios, something that, in the modern universe, we only find in the oldest star clusters of the Milky Way. The universe seems to be sending a defiant message. We were here. We lived, we died, and we scattered our remains across space before you even thought we could exist. If these galaxies are real, and then 99% of current cosmological models are on the brink of collapse, suddenly our decades-long confidence in an orderly, sequential universe has become fragile. We are entering an era where confusion is the beginning of knowledge. You have to wonder how many more such monsters are hiding in the darkness, waiting to tear up our final textbooks? Are we looking at a completely different universe? One with a memory and a speed of operation faster than anything we dared to imagine? Hubble tension and the betrayal of constants. While the monster galaxies are shaking the timeline of the early universe, in another corner of theoretical physics, a single number is quietly creating another lethal crack in the structure of the Standard Model. That number is the Hubble constant, named after Edwin Hubble, who first realized the universe is not static but constantly expanding. This constant describes the rate at which space is being stretched. If you can hold it precisely, you can calculate the age of the universe, the speed of structure formation, and the distant future of all things. However, the universe appears to be giving two different answers to the same question. For decades, cosmologists argued fiercely over this value. By the early 2020s, the two most credible measurement methods emerged, but they were completely inconsistent with each other. The first method looks back at the distant past by using the Planck satellite to map the cosmic microwave background, the afterglow of the Big Bang. The result Planck gave was 67.36 kilometers per second per megaparsec. The second method looks at our neighbors, directly measuring nearby objects like Cepheid variable stars and Type 1a supernovae. Adam Rees led this research group and provided the figure 73.04. The gap between 67 and 73 sounds small, but in physics this discrepancy has reached 5 sigma. To help you visualize, 5 sigma is the official threshold for declaring a new discovery in particle physics. And when applied to a disagreement, it means something is seriously and fundamentally wrong. Many hoped this was just a technical error of old measuring equipment. They expected the James Webb Space Telescope, with its superior resolution, to separate stars that Hubble once saw as blurred together and erase the error. But in December 2024, Webb gave the final verdict. The local measurement was accurate. The error was not in the machines. The error was in our understanding. Hubble tension has now become a Hubble crisis, Daniel Skolnick declared. If both measurements are correct yet yield different results, what does that actually mean? Does the early universe and the current universe operate under different physical laws? Theoretical physicists are facing painful choices, each requiring the tearing up of a textbook chapter considered set for decades. Option 1. There was an unknown energy source in the early universe, an early dark energy that provided a kick causing the universe to expand faster than expected right after the Big Bang. Option 2. Dark energy, the repulsive force expanding the universe, is not an unchanging constant as Einstein once thought, but changes over time. And option 3, in the most extreme, the cosmological principle is broken. We have always assumed this universe is homogeneous and isotropic, looking the same in every direction. But what if it isn't? What if the universe has a preferred direction or an axis of symmetry we have never recognized? The greatest ache is that every proposed solution requires the existence of things never directly observed. We are adding invisible cards to a house of cards just to keep it from falling. At what point does patching a model turn into building a completely new model that just carries an old name? This question opens a deep abyss. If even the most fundamental constant of existence is no longer reliable, are we living in a universe not designed for humans to fully understand with current mathematics? Have you ever wondered, if our yardstick itself is expanding and contracting, how do we know where we truly stand in this eternal flow? As scientists diligently search for the solution to the expansion rate, James Webb has sent back another mystery, a light that should have never been able to escape the fog of the past. Light piercing the fog and the mystery of little red dots. In the timeline of cosmology, there is a period called the Epoch of Reionization. Before this stage, the universe was covered by a thick fog of neutral hydrogen gas. This fog was extraordinarily efficient at one thing: absorbing Lyman alpha radiation, a type of ultraviolet light produced by vigorous star formation. According to the Standard Model, any Lyman alpha signal emitted before reionization was complete would be swallowed and never reach human lenses. However, James Webb found the galaxy JADES-GS-Z 13-1 at 330 million years after the Big Bang. Strangely, it is shining brightly in the Lyman alpha wavelength. "We really shouldn't have found a galaxy like this," researcher Kevin Hainline exclaimed. "How could that forbidden light successfully escape?" There are two possibilities, and both require us to rewrite history. Either this galaxy created a massive ionized bubble around it for light to escape, or the hydrogen fog of the universe was actually thinner and vanished much earlier than we thought. A 2024 study concluded that this process finished 350 million years earlier than predicted by the LCDM model. Open question: if the first light found a way to pierce the darkness so early, was the early universe truly a dark and lonely place, as we long imagined? Or was it brilliant and bustling from the very first moments? The astonishment did not end there. As James Webb began deep surveys into the void, scientists noticed tiny, extremely bright red spots scattered throughout the first billion years of cosmic history. They called them little red dots. By 2024, 341 such objects had been cataloged, and they do not fit any known category of object. Initially, they were thought to be extremely dense starburst galaxies, but spectroscopy refuted this. Attention then shifted to supermassive black holes actively eating gas. But if they were black holes, they should emit massive amounts of X-rays. Yet among the 341 objects, only 2 emitted X-rays. In early 2026, the debate reached a peak when 2 leading research groups released completely opposite conclusions in the same week. One side argued they were young black holes wrapped in thick cocoons of gas, while the other claimed they were supermassive stars 1,000,000 times the mass of the Sun, a hypothetical object never directly seen. The universe seems to be playing hide-and-seek with humanity's greatest minds. We are not failing due to a lack of effort. We are confused because these objects do not obey the physical classifications we have built over the past century. Open question: are we standing before a completely new form of matter and energy? Is there a law operating in the darkness that James Webb has only just begun to scratch the surface of? The mystery of these red dots leads us to an even bolder hypothesis. What if the universe did not wait for stars to die before building black holes? Could there be primordial black holes forged from the violent density fluctuations of the Big Bang itself, acting as steel seeds for galaxies to cling to and grow at dizzying speeds? Webb's journey is no longer a stroll to confirm what is known. It has become a crime scene investigation for a case where the victim is our own belief in our understanding. The price of relearning in the Nancy Grace Roman verdict machine. Behind the redshift numbers and dry spectroscopic charts lies a silent tragedy of those who do science. There is a very high price for this revolution that no article mentions: the price of relearning. Think of Professor Allison Kirkpatrick at the University of Kansas. She spent her career building an intuition for how galaxies form based on the LCDM model. She taught it to students and used it to win grants and build a personal reputation. And then Webb sent back data saying the map she held in her hand did not match the ground beneath her feet. She admitted to lying awake at 3 in the morning, wondering if everything she ever did was wrong. This is not just self-doubt. It is the vertigo of having to dismantle an entire belief system to rebuild from scratch. Open question. Do we have enough courage to admit we were wrong? Or will we cling to the fragments of an old theory just because it is familiar and safe? However, within that fear is also a powerful exhilaration. If the old map is wrong, the new territory out there is more interesting and vibrant than anything we ever imagined. Science is progressing as it should, breaking old models to create deeper insights. Cosmology is currently deeply divided. One group still bets the old model will survive through computer refinements. A second believes a fundamental overhaul is needed. And a third, small but growing, has begun using the term paradigm shift, a total revolution. This uncertainty will not last forever. The final verdict is being assembled right now, the Nancy Grace Roman Space Telescope. If James Webb is a super-sensitive lens looking through a keyhole to see anomalies, Roman will throw that door wide open. With a field of view 100 times larger than Webb, Roman will not look at postage stamp pieces of space, but a massive poster. In the late 2020s, when Roman officially opens its eyes, it will sweep across millions of galaxies instead of dozens. It's the statistical numbers from Roman will be the most definitive answer. Either Webb's findings were rare exceptions, or this universe is truly older and more complex than 13.8 billion years. Open question. When Roman delivers its verdict, will we see an orderly universe as before, or a reality so strange that humans need to redefine their own place in the timeline? The story of James Webb has never been about accumulating answers. It is about refining the questions. We have gained some of the best questions in human history. How did the first light organize matter? Does the universe have a memory or a preferred direction? Is the model we use a solid foundation or just a temporary scaffolding? In the freezing darkness of Lagrange 2, the golden mirror is still silently turning. It does not care about the careers of scientists or arguments on the ground. It simply receives photons that have traveled billions of years to tell us a truth that perhaps we were never humble enough to hear. Final open question. Will you choose to believe in the old, verified textbook pages, or choose to step into the darkness with James Webb to face a truth that could change everything you know about yourself?